Okay, I am going to cover today's worksheet, the 14.1 Peach worksheet. And I'm only going to cover two problems just to make sure you were doing them right. Mr. Kuntz will put the answer key up after this recording is done. I did the worksheet last night and I thought some of them were okay. I thought you could get them on your own, and then I thought a couple of them were a little harder than the rest. So I thought I'd kind of guide you through number 4 and number 8. So let's go after number 4 right now. Okay. Remember yesterday I said you've got to get rid of tangent, cotangent, secant, cosecant. You want everything to be sine and cosine. Okay, let me get this copied down. Okay, there it is. And this should equal secant of theta times cosecant of theta. Okay? All right. First thing, let's get rid of tangent. Now, tangent is also sine over cosine. Plus cotangent is cosine over sine. Okay. Now remember, if you have an addition problem, which we do, let's get common denominators. So the common denominator, this one's kind of tricky. It's got cosine and sine on the bottom, and you're going to have to go back 5th, 6th, 7th grade and say, what did you do when you had this? 1/3 plus 3/5. What did you do to get the common denominator? Most likely, you just thought it out, 15. But really what you're doing is you're just taking these two numbers and you're multiplying 3 times 5. Now 3 times 5 is the common denominator, but sometimes it's not. But no matter what, it is a common denominator. It might not be the lowest common, but in this case it is. But this will always get you the common denominator. So in our case, we would take sine times cosine, just multiply them, and that becomes the common denominator. Whoops, forgot my theta. Okay, cosine of theta, sine of theta is the common denominator. Okay, now your job is to turn each fraction into cosine sine. Well, to turn the bottom into cosine sine, you'd have to multiply by sine of theta, and there the top becomes sine squared. The bottom multiplied by cosine of theta, and the top becomes cosine squared. Oh, well now you got to look and say, well, you're adding two fractions. The numerators get added, and you cannot join a sine function with a cosine function. So they stay apart. They don't get joined together. So the common denominator doesn't change. It never changes. It just stays exactly the way you had it. Cosine sine. Well, by looking at this, it looks like on top you got sine squared plus cosine squared. And if you look at your little cheat sheet that Mr. Kuntz has given you, the identities, it says on the Pythagorean, cosine squared plus sine squared is 1 over cosine of theta times sine of theta. Okay. And now if you look on the right side of this equation, it says secant times cosecant. Well, what you have here, you basically have a fraction 1 over cosine and 1 over sine. So if you really wanted to, you don't have to do this, but you could just break it apart into two separate fractions. We do know that this fraction and this fraction, when multiplied, does give you this. So this is the same thing. And we now know that 1 over cosine is just secant of theta times cosecant of theta. Exactly what we wanted up top. Okay? And this is now verified. We proved that the left side is the right side. Okay? So this is how you would have done number 4, and number 4 was pretty difficult if you ask me. Another one that's a little different is number 8. So just take a look at 8. Number 8 is cosine of theta times secant of theta minus cosine of theta. Okay? And it should equal what? Oh, sine squared. Okay, now, looking at this over here on the left side, you could change this if you wanted to. You could change it right now if you want to change to 1 over cosine of theta minus cosine of theta times cosine of theta. All right. Now, you could go inside and do what's in your grouping, so you could add these two together. But to be honest, I would just run your multiplier through. I would distribute it through once, twice. Here it's cosine over 1 times 1 over cosine. Here the cosines would cancel out, and you'd end up with 1 minus cosine times cosine is cosine squared. Okay, now it looks a lot better. Now looking at this, 1 minus cosine squared, well, you got to remember your Pythagorean identities. Okay, there is the Pythagorean identity. You have 1 minus cosine. Well, if you just get the cosine over here, it's going to say 1 minus cosine. So to me, subtract cosine squared, and you end up with sine squared equals 1 minus cosine squared. Hey, that is what we have. So this becomes sine squared. Exactly what we wanted. Okay, so that takes care of the Peach worksheet. I did 4, I did 8. The rest of them, you know, I think they're doable. Please look at the answer sheet that Mr. Kuntz will put on the board halfway through the period. Okay. All right. Now, he should now give you the 14-1 day 2 worksheet. So it's the same thing. We're just going to take a look at it. I did write down a couple things about it. Just to help you out a little bit, some of the Pythagorean identity problems would be like 1, 5, 6, and 8. Okay? If you ever want to just multiply, because that's all it is multiply, 7, 9, 11. Now, I'm not going to do any of these because I think that's the easiest problem for you guys. I also think division is easy, but I'll do one of these. Dividing problems would be 3, 4, 5, 6. So these are all about the same, okay? And then, of course, what is going to be hardest for you is add and subtract, okay? And those are 2, 10, 12. 2, 10, 12 is add, subtract. And that takes care of today's assignment. I thought here, let's try number 6. Okay, so this is you and I doing this. I also thought multiply, I'm not going to do any of these because I just think you guys are pretty good at this. This is just cancel like functions. Answers come pretty quick here. This is like a quick problem. Now, division, division is really just multiplication, except a little tricky. So let's do number 5. And then now add, subtract, let's do the last one, 12, okay? Okay, so I'm doing 6, 5, 12. 6, 5, 12, here we go. Number, hang on, did I want another one? Yes, division. Oh, no, I think this is good enough. Okay, so here we go. Number 6, Mr. Kuntz, I think what you should do is let them work on 6 for a couple minutes and see what they do. Okay, so pause the tape or the recording and just let them work for a couple minutes. And then come back to this. Okay, now that Mr. Kuntz let you work for a couple minutes, let's take a look at this. First of all, I hope you, your partner that you're sitting by, recognize this as a Pythagorean identity. Now remember, this is a Pythagorean identity. Okay, right there. Now, you don't have that, but what you have is secant minus tangent. So if I just did this, 1 should equal minus tangent squared minus tangent squared. So secant squared theta minus tangent theta squared equals what number? 1. So what you could have done, you could have just done this. Put a 1 in that spot. So it's sine over cosecant of theta. And this is now become a pretty easy problem. It's sine of theta over what? Cosecant. Oh, well, get rid of cosecant. Sine of theta over 1 over sine of theta. There you go. Oops, wrong way. Still the wrong way. Okay. All right, so this now over here becomes sine of theta times the reciprocal sine of theta. Answer? Sine squared. Yeah, we got it. There it is. Okay. All right, so number 6 is now done, and that is a Pythagorean kind of problem. If you recognize 1 and 5 and 8 are kind of the same thing, life will be easy if you recognize that. Okay? Now let's go after number 5 on division. I don't think division is that hard. I just want to try one. Okay, number 5. Here we go. 5, 5, 5. Where are you? Okay. All right. Good. 1 plus tangent squared theta over 1 plus cotangent squared theta. Okay, Mr. Kuntz, pause the tape. Let him work. Come back in 3 minutes. Okay, now that you've worked, Mr. Kuntz, thank you. Now let's do this again. 1 plus tangent squared, doesn't that look like a Pythagorean? That equals what? That equals secant squared of theta. So you could just replace this with secant squared. Where 1 plus cotangent is another Pythagorean, you could just replace this with cosecant squared. And now it became a division problem with just 2 functions, secant divided by cosecant. So this is back to division now. So in division, we would take 1 over cosine, which is what secant squared is, 1 over secant. 1 over cosine squared divided by 1 over sine squared. And now, division is really just multiplication. So take 1 over cosine squared times the reciprocal sine squared over 1. Okay. You would just multiply straight across. It is sine squared over what? Cosine squared, right? And this looks pretty good, except sine over cosine is now known as tangent. And since it's squared over squared, it's going to be tangent squared. Okay, and that would be number 5. All right, and there were some addition, subtraction problems. Oh, they're right here. Hang on. They are 2, 10, 12. And I thought they're average to above average problems. They're a little difficult. So let's try 12. This might be my last one right here, guys. 12 is cosecant of theta, subtract sine of theta equals tangent of theta. The nice thing about this one is you know what you're supposed to get. you are proving, okay, the word they use is verify, but verify just means what? Prove that cosecant minus sine is really cotangent times cosine. So here we go. Again, this is a subtraction problem, so we need common denominators. Let's go get them. Well, first, sine is good. I like sine. I don't like cosecant. So this cosecant can be just called 1 over sine. That is your reciprocal identity. Minus sine of theta equals that stuff. Okay, here we go. It's a subtraction problem. So what's the common denominator? Well, you take the denominator sine of theta times the other denominator, 1. That is the common denominator. So you want what on the bottom? Sine of theta minus sine of theta. Okay? Well, the first one, you don't have to change. The second one, you need to multiply by sine on the bottom, sine on the top. Okay. You would get sine squared on top. There you go. And now you have two fractions with common denominators. Go ahead, subtract them. 1 minus sine squared on top over sine on the bottom. Well, this looks like Pythagorean right here, doesn't it? You got a trig function sine squared with a 1 with a 1 next to it. So once again, you got to think, how do I get this to look like the top up there? Well, you would just take the sine and move it over here with the 1. So it would be cosine squared equals 1 minus sine squared. Okay, so that means the top is what? Cosine squared over sine squared. No, just sine, sorry, just sine. Okay. Now, remember, this is supposed to equal what? Cotangent times cosine. Okay, now, if that's true, somehow this has to be cosine over sine times cosine. Well, if you look back here, guys, you have a cosine squared on top of a sine. So really, isn't that cosine of theta times cosine of theta over sine of theta? And you should recognize this right here. Whoa, sorry, this one right here as cotangent. So cosine over sine is just cotangent of theta times, and then this cosine, you know, it just doesn't have anything else to go under, so you got to go like this, is multiplied by cosine of theta. And that is what you were trying to, prove the whole time, right there. Okay. And that is number 12. And I thought number 12 was pretty difficult. So that's it. Mr. Kuntz, let him work now with the rest of the period. And hopefully they can function on a Friday afternoon and not drift. Okay. Really quick. I went to the play last night and I thought the play was awesome. You guys did a nice job. Period 6, Gavin, Adrian, Annalise, awesome, way to go. It's been a nice 2 weeks with the hockey team winning the state championship and the girls hockey team in the state championship, and the Central girls beating Red River last week. Wow, hopefully we continue this. Okay, you guys have a good afternoon. Finish up your assignment. Enjoy your weekend. I will talk to you on Monday. Thank you for listening. Thanks, Mr. Kuntz.